Here we're going to start off our Unit 5, going over logarithmic and exponential equations by just talking about what logarithms are, because those are some things that you probably haven't seen before. And so today's going to be your introductory video to that. First thing we have to answer is really what a logarithm is. A logarithm, whoopsies, is the inverse operation of an exponent. What it helps us do is to be able to solve some problems where our variable or our unknown quantity is an exponent in that problem. As we go through this chapter, we're going to get to a lot of different application problems that show you where that comes into play. But a lot of what you're going to see is that the variable or your unknown is in your exponent, and we're going to use a log to get it out of the exponent. If you don't remember, an inverse is just what undoes that operation. So for example, addition and subtraction are inverses because they cancel each other out, multiplication and division, and now logs and exponents. Okay, so we use that to be able to solve really an exponential equation, which we'll get to. How we write them, you could have some log base b of a, and again that's read log base b of a, and that could be equal to some quantity x. To put that into exponential form, how you would convert that, your base down here is the base of your log. It would also be the base of your exponent. Your unknown is your exponent. And then the a is the number that was in your log before. Okay, so these two equations say completely equivalent things. And what we're going to do is talk through how you go back and forth between these easily, oopsies, so that we can learn to solve these equations, whether in our head, with a calculator, whatever it is. But again, your log, your base of your log is also the base of your exponent. Whatever the log equals is your exponent. And then whatever number's in your log is your a, or is on the other side is your answer. We have a couple important logs. Okay. The common logarithm is always log base 10. And how we write this common log is just log with no base next to it. So say log of a. Okay, that is the exact same as me writing log base 10 of a. We just don't have to write the base. Okay, this is the button on your calculator. So if you look at your calculator, you have a button that just says log with nothing after it. It is the common logarithm, or your base 10. Okay, that's our common logarithm because in science we use a lot of base 10 information. Your scientific notation is always, like converting is always base 10 between the metric system. And so that's where this comes from. For your natural logarithm, that is going to be log base e. And e is called Euler's number, E-U-L-E-R-S apostrophe. And that's just the man that found it. Whoopsies. Okay. E will come in a lot into play when we're dealing with application problems. It deals with when things are compounded continuously as they grow over time. And so that's going to be really big later on. In your calculator, if you have an E button, and if you just type it in, it will calculate that number for you. That button is usually on your natural log button, which I'll get to what that looks like in a minute, but E is about 2.71828 and so on. So you should have an E button on your calculator, and it can calculate your Euler's number for you. How to find this, the way we write it is just as ln of some a. And again, it is the same as log base e of a. So you should have a button on your calculator. Both of these have a button that you can just use. Okay, so your common log is anything base 10. Your natural log is anything base e. And again, they both have a button on your calculator. What we're going to get into at first is really just converting and being able to go back and forth between the forms. So at first we're going to convert from logarithmic form to exponential form. And we're going to talk just about how I do this and some memory tricks that can help. We talked a minute ago just about how you group the pieces. The base down here is always the base of your exponent. whatever your answer was is always your exponent. And then your of that 9 is always what it's equal to. And when I give you these, they're always going to be accurate. I'm not going to make things up that are not accurate statements. So you can use that to help you check. And we do know that 3 squared is 9. So these two equations are equivalent. This would be your logarithmic form. This would be your exponential form. One thing that can help, and I'll just write it out real quick, is what I call kind of around the world. To convert this down to your b to the x equals a, I think of it in a circular motion. You always start at your base, and you'll go to your x and then over to your a. So again, it's b to the x equals a, and that circle can sometimes help you out if you forget really where things go. So again, we could have looked at number 1 and said, hey, it's 3 squared equals 9, just going in a circle. We're just going to keep practicing that on here. So here's 6 cubed equals 216 would be how you would write it. And again, if you want to check it, 6 cubed is in fact 216, so it's correct. What I would do, go ahead and try these 3 and make sure you verify they're correct in your head, and then pause or play the video so that you can talk through it. So on number 3, we start with the base. So 7 to the 0 equals 1. And again, we know our exponent rules of anything to the 0 power is 1, and so that's correct. On number 4, 2 to the 4th equals 16. And if you check it, 2 times 2 times 2 times 2 is 16, so that's correct. On number 5, 4 to the negative 2 is 1 over 16. This can be a slightly harder one to check because of that exponent, but remember that anything to a negative power really just flips over the fraction and puts that term in the denominator. So it doesn't flip the whole thing, but it flips whatever's raised to the negative power. So this x would go to the bottom, which is why here it really became 1 over 4 squared, and 4 squared is 16. On number 6, it's 9 to the 3 halves equals 27. Again, this can be an interesting one to check. It goes all the way back to first semester. From first semester, we talked about how rational exponents give you a radical. So that 2 on the bottom is really telling you it's the square root of 9 cubed. And way back when we did this, we talked about you can do the root or the exponent first, it doesn't matter. So if I do the square root first, square root of 9 is just 3, and then 3 cubed is 27. So this does in fact check out. Those exponent rules are going to be more and more important as we go, so just make sure you're practicing it. Then we're going to convert the other way as well. So going from exponential form into the logarithmic form. When we do this, you can use a similar trick to what we talked about on the last slide. And so I will write that down for you, but you can also just kind of memorize where things belong. It's totally up to you. To go back the other way, again, your base is always your base. This is going to be log base 14 of this exponent's going to be over here now, so it's always of this other number on the other side. So of 196 equals 2. And what you can also do if you want is we can use that kind of around the world trick that I showed you on the last slide. Always start with your base, so it's log base b of whatever's on the other side, so your a, equals the x. So you can do this circle in both directions is kind of the nice thing. Checking these is a little different, but it's good practice for getting your brain to think more of like logs. And what you want to think about, 14 to what power is 196? The answer there is 2. 14 squared is 196, and so that's the correct answer. So you're kind of converting it into an exponent in your head, but making sure that it makes sense. If we rewrite the next one, the base is going to be 3. So log base 3 of 81 equals 4. So again, you can go in that circle. And what I do to check, 3 to what power is 81? And so long as my answer is 4, that means I did this correctly. Just like on the last slide, go through that 9 through 12 there and make sure that those make sense, and then hear an explanation so that if you have any questions, I can answer those for you. On number 9, Your base is this first 12, so log base 12 of 12 equals 1. And again, if you're checking it, 12 to what power gives you 12? Well, that would just be to the first. On number 10, log base 36 of 6 equals 1/2. And again, you're thinking, hey, what do I need to do to this 36 to get it to be 6? Well, I need to square root it, and square root would be this fraction. Going on to number 11, log base 2 of 1/8 equals -3. And then again, I would check it. To get from a 2 to a 1/8 using an exponent, you need a negative, which is why we have that negative right there. And then 2 to become an 8, you would need to cube it. And so that's how I get to the 1/8. Last one on this page, log base 8 of 16 equals 4/3. Okay, this is a harder one to check. What I would do, this 8, you want to shrink it down to be a number you can raise to a power and get 16, because I can't raise 8 to a clean power and get 16. I can cube root 8, which gets me 2. And then if I raise 2 to the 4th, I do get 16, which is where that 4/3 come from. So even if you can't think it straight through each time by yourself, make sure you're verifying. So if I cube root my base, which is what it has here, I get 2. If I raise it to the 4th, I do get that 16, so it is probably the correct answer. Okay, what we're going to start doing now is actually evaluating, where I'm not going to give you the answer, I'm just going to give you the equation. So we're going to talk through these ones and then give you some to try by yourself as well. What I would do often with these is think about setting it equal to x and writing it in exponential form if you need to, because often at first we have to get used to what these logs mean, with the goal being that eventually you don't need to write it in exponential form and you can just think it through. If I rewrite this in exponential form, it would be 8 to the x power equals 64. And now you're really just thinking, hey, what power do I need to raise 8 to be 64? And the answer to that is 2. Again, my goal is eventually you look at this and say, hey, 8 to what power is 64? Answer's 2, and I'm done. But for now, I will keep rewriting it all the way out to help you through that. So if we try the second one, again, I set it equal to x so that it's easier to rewrite. So 2 to what power is 1/16? And to think this through, I'm going from a whole number to a fraction, which means I need a negative exponent, so my fraction flips over. And to do 2 times itself, how many times gives me 16? Well, that would be 4. So my answer is just -4. Go ahead, I would try these next two, and then when you're ready for an explanation, click play. And if you just need one now to help you out, go ahead and just keep listening. When I rewrite this, this would be 64 to the x equals 4, or if you're just reading the problem as is, 64 to what power gives me 4? Well, I know since I'm going from a big number to a small number, it needs to be a radical. If I square root 64, I get 8, but if I cube root it, I get 4, so my answer needs to be 1/3. On this next one, same idea. 81 to what power equals 9? Again, I'm going from a big number to a small number, so I need a root of some sort. Square root of 81 is 9, so that means my answer is just 1/2. Okay, I would go ahead and try some of these, and then when you're ready, click play and go ahead and listen to the explanations of these answers. So, okay, if I rewrite this one, it's 1/3 to what power equals 27. With this, I have a fraction and I need it to be a whole number, so I do need a negative exponent to flip that 1/3 over. If I do 3 squared, that's 9. If I do 3 cubed, that's 27. So I would need to raise 1/3 to the -3rd. On this next one, it's going to be 5 to what power equals 1? Well, if you remember our rule from before, anything to the 0 gives us 1. On the next one, sorry I didn't number these, 7 to what power is 1/7? I need to flip that fraction over, which is a negative exponent, and it stayed a 7, so it's just a negative 1. And the next one, 4 to what power equals 4? Well, I'm keeping the number the same, so it's just going to be 4 to the first power. On the next one, 343 to what power equals 1/7? This one has a lot going on. I notice it goes from a whole number to a fraction, so I know it needs to be a negative, because I have to flip that over somehow. It's also going from a big number to a small number, from 343 down to 7, so it needs to be a fraction. It's going to be a radical. I can't square root 343, but I can cube root it, and if I cube root it, I do get 7, so it's going to be 1/3. On this next one, 4 to what power equals 256? And that's going to be the 4th power. These ones are going to deal with our common log and our natural log. And what's important here is that you remember anytime you see ln, it's really base e. So if I'm rewriting this problem, it's going to be e to the x equals e. And if I look at that, this e, remember, is still to the first power, so this is just x equals 1, much like this one was. Okay, so even though it's kind of ugly, it doesn't matter. If we try the second one, e to what power equals e to the 9th? Okay, don't overthink this one. The power you would have to raise e to would be the 9th power. On the next one here, if there is no log, remember that's really a 10. So you are figuring out 10 to what power is 10,000, which should be, whoopsies, cubed. Oh, nope, 4th. 10 to the 4th. And on this last one here, 10 to what power gives me 1/1000. It needs to be negative to flip the fraction over, and then it's cubed, so make 10 be 1,000. What we've looked at so far is all ones that you can do in your head, and you will have a no calculator quiz over that type, but we're also going to talk about how you just evaluate logarithms if you either can't do it in your head or you can't think of what that answer would be. And we have what's called the change of base formula. What it tells you is if you have log base b of a, you can always type it into your calculator, so long as you know one of these two following formulas, and you can use either one, it doesn't matter. You can do the log of a divided by the log of b, and that would be using your common log. Or you can do the natural log of a divided by the natural log of b. So you can actually use either calculator button that you want, either your common log or your natural log, to evaluate a logarithm. Again, if either it's impossible to find a value, or if you can't think of that value. And some examples for that I have here. Okay, this first one here, if we tried to evaluate it, 5 to the x equals 97. There is no number we can raise 5 to make it be 190, or no clean number to make it be 97, because 5 squared is 25, 5 cubed is 125, and that's already bigger. So I know just from logic that this answer should be somewhere between 2 and 3, because 97 is between 25 and 125, but I can't get that number off the top of my head. So what I can do, though, is use my calculator. When I rewrite this, this is going to be log of 97 divided by log of 5, and then you just type it in. And it will tell you for this one, for example, that it's 2.842 for that. Okay, we're just going to practice using our calculator on some of these, and I will switch between the two formulas because it doesn't matter. Again, on this one, 3 to what power is 1/30? Well, there's nothing that'll work on that. 3 cubed is 27. 3 to the 4th is 81. So this is impossible to raise 3 to a power and get 30. So I can use my formula. This time I'll use natural log. Again, it doesn't matter. If you use log in your notes, it'll be the same answer. We do natural log of 1/30 divided by natural log of 3. And it gives me negative 3.09, we'll call it 6. Just bigger than 3, and 3 cubed was 27, so that does make sense. When we go to this next one, 4 to what power is negative 3? I want you thinking about this. Is there any number I can raise 4 to and get a negative? And what I'm going to hope your answer to that off the bat is no, but I'll show you that it doesn't work in your calculator also. If you have a negative inside your log, your answer will always be no solution, because you cannot raise a positive number to a power and get a negative. And with our logs, this base will always be positive, but your calculator will tell you error if you try typing it in. So if I try doing log of negative 3 divided by log of 4, it should say error right out of your calculator. So again, you will never have a solution for a log of a negative. Try this next one by yourself and then go ahead and listen through. Okay, 5 to some power is 110. There's no way to do that, so I do have to do, this time we'll use natural log. Again, you can do either. Natural log of 110 divided by natural log of 5 gives me 2.921 if we round. Okay, I want you to go ahead and test these ones out and make sure you know how to type those in. Then listen to the video, and then this is the end of your notes. Okay, if we start thinking through this, this would be 6 to what power equals 0. And again, this is one I would think through also. What number can you raise 6 to and get 0 as your answer? Okay, with this one, there's nothing we can raise 6 to and actually get a 0 as an answer. We can get very close to 0. We could be a rounding error away from 0, but this will also actually give you no solution. If you didn't notice that when you tried to think it through, you still can type it in your calculator and it will tell you error. Okay, but you cannot raise 6 to a power and get 0 as your answer unless you rounded, and so that would just be your answer. Okay, here, natural log is e, so e to what power is 56. Those ones you will never be able to solve in your head, and that's okay. The trick I had for you here, I want to make sure you're not trying to use your change of base when it's just natural log. Just type that number in your calculator. You don't need to change of base it. You can just type in natural log, oopsies, of 56 is 4.025. Your calculator will just give it to you. There is no need to type in a change of base if it's a natural log, or for the matter of these ones, a common log. Okay, remember, if there's no base written, it's a 10. So this is really 10 to what power is 450. We don't know off the top of our head, so we can just do log of 450. Again, you don't actually have to type in change of base because your calculator has this button. Last but not least, this is 10 to what power equals 1. Well, this one I can actually do in my head and get 0 as an answer. You are welcome to test it if you don't believe me, but just use that log button. Since it is your common log, just use that button there.